Okay, all right, so data visualization. So to recap from yesterday, we talked about pivot longer and pivot wider and how they can help us reshape our data. This is especially useful for data visualization because we often need our data in long format, which we'll talk about. So we can use pivot longer to do that, to get our data from wide to long format. And we have a names to argument that provides the name that we want for the pivoted columns, for the names of the columns to go to. And the values that come from those columns, we name that new column with values to. And then pivot wider does the opposite. We have the column that we describe to take the names from using the names from argument, and the column to specify where the values are from the values from column. And recall that to merge and join data sets together, you generally need a variable that's in common, which is usually some sort of ID, and sometimes you have to specify it like we did in our lab. And there's the cheat sheet. And we talked about lots of different types of join functions, which you can see using !join, and they come from dplyr. We talked about how inner join takes only the rows that match both X and Y. Full join takes any of the rows of either X and Y and those that match. Left join takes only those that are either in X or also in X and Y. And right join takes all those that are either in X and Y or just in Y. So it preferentially prefers the one on the right, whereas the left join preferentially prefers the one on the left. Anti-join keeps only those that are not in either, are not common to both. And we use the esquisser function of esquisse to create our sketches. And so indeed, if you look at the hex stickers, esquisse helps you to create a sketch of plots, whereas ggplot2 does really similar things, but it's making the code directly. So if you have esquisse, why do you need to learn how to use ggplot2? Because you can do so much with it. Well, there's some things that you can't quite do. There's some extra customization that you can do with ggplot2 that's sometimes really important. You can do extra branding and color changing, and you can make your plots interactive. You can combine plots. So there's some things that you can't quite do in esquisse. But also, eventually, it might be faster for you to create plots using ggplot2. For example, say you wanted to iteratively make a bunch of plots, you could write a script that helps you do that. And to do that, you would need to know how to generate a plot. And this may be hard to believe, but eventually you'll actually be faster because you'll know exactly how you want to create your plot. Okay, so why is it called ggplot2? So GG stands for Grammar of Graphics, and it was created by Hadley Wickham in 2005. He's one of the RStudio people that we've talked about, and so it's part of the tidyverse family of packages, and it's one of the most important. It's so important that people don't even say, make a figure, make a plot. They'll say, make a ggplot. And they're describing using the ggplot2 package. If you want resources about how to make even more plots, I'd check out the ggplot2 book, and also open case studies. We describe a lot of special types of plots. All right, so the major concept to keep in mind for ggplots is that we're going to layer different pieces of plots on top of one another. And so we're going to use this plus sign to put our plots together and layer them on top of one another. So ggplot2 is extremely powerful and flexible. You can really customize almost everything by adding all these different layers, but it's going to be a little bit tricky because it's a little bit confusing. So we're going to walk through this slowly, and the more you combine using eskies and practicing, you'll start to pick up the code. If you make sure that you look at the code that the eskies generates. If you take a look at the ggplot2 gallery, you can see some of what's possible with ggplot. You can add arrows, you can add boxes, you can add a cross sign, you can have plots on the outside of plots, grid lines that are really large, you name it. You can reorder things. We'll talk about that later. You can add text. There's just an incredible amount of things that you can do. So I check out this gallery if you're interested to learn more of what's possible. This crazy plot. Yeah. All right. So in order to make a ggplot, you need to have your data in tidy format. And so how you do that is by using all of the functions that we've been talking about to wrangle your data, particularly what Ava was talking about yesterday in terms of reformatting our data frames to be in long format. But also importantly, having each variable as a column and each observation as a row. So anytime you have messy data where your column headers are values and not variable names, or you have multiple variables stored in one column, which we learned the separate function can help, or you have variables stored in both your rows and your columns, you're going to want to fix that, clean it up to help you be able to plot it the way that you want. So as an example of what would be not exactly tidy and not long format, here we have a data set where we're looking at different religions and values of money. And here we can see that we could put, we don't, this is the religion, but these are values of money. And we could really transform this so that we have this in long format, and that we have repeated, values of agnostic, for example, with these different money values. And so indeed, that's what we would need to create a plot. So if we use pivot longer, we could get our data to look something more like this, where we've repeated agnostic and we have our income and the frequencies. If you're confused about whether your data is tidy and what you might need to do with that, there's a tidy data tutorial specifically here. All right, so let's get started. Okay, so we're going to use some data that we saw yesterday in the lab briefly. It's data about orange trees, and if you're interested in more about it, you can type $orange into your console. But it's basically information about several trees and their circumference after a certain number of days. And so, is this data tidy? Is it in long format? Yes, it is. It's ready to go. It's in long format. Because we have different information in each column. We don't have, basically in our other situation where we have a variable across columns. And we can see that tree 1 is repeated so that we can have our age and circumference variables in a long format. Oops. So we're ready to get started. So let's make our first plot directly in ggplot2. All right, so first let's go over the structure. So there's a very important piece, which is mapping out which variable goes where. So we're going to use an argument called mapping, which will take a function, AES aesthetic, where we describe what's going to be on the x value or x-axis and what's going to be on the y-axis. And so first we would need to install and load ggplot2. So that would be the first most important thing to do. Otherwise this won't work at all. And we need to use the ggplot2 function to specify what data we're going to use to plot, and also the mapping. So again, we put our aesthetic and then the x-axis variable to plot, and for the y-axis, the variable to plot on the y-axis. So this is kind of a strange structure that we haven't really seen before. And technically you can do it without the mapping equals argument and just directly put AES. But it's a little bit helpful in the beginning to understand what exactly you're doing with the AES function. And what you're doing is mapping out where the variables and other items, we'll talk about that later, go on the plot. So to create your first and empty plot, so when you just use this, you're going to create an empty plot. We'll put orange as our data that we're going to use, and then mapping equals AES, and our x-axis will put the circumference variable, and our y-axis we're going to use age. So the output of this is this plot. It's not very exciting, but we can see that age is indeed on the y-axis and circumference is on the x-axis. And like I said, ggplot2 is all about layers. So we're going to have to add layers to show how we want it to be plotted. Is there a question, or is that just an accident? Okay, I think not. All right. So to add actual points or lines or bars, we need to add on another layer. And there's a bunch of ways that we can do this in ggplot. Okay, so I'm gonna also add our studio to my share. And so can we see my RStudio as well? All right, thanks.
Yep.
So if I load my library, ggplot2, make sure that you're doing that first. I can pull up ggplot. Let's do this. I can type in geom and I can scroll through to see all these different types of plots that I can make and read about them. You can also look through the gallery to see what kinds of plots I can make. So this is a good way to find out what's possible. We're going to talk about some of the major ones though that you'll mostly use. Okay, so we saw geom point a little bit last time. Can we see my slides now? Just checking. Yeah, okay, thanks. So we saw how this helps us make basically scatter plots where we have points on our plot. And the geom line we also saw where it basically draws a line between different data points. We can also create box plots and histograms, which is similar to our hist function that we saw previously. We can make bar plots, column plots. Those are pretty similar, just slightly different. Bar only takes one mapping and looks at frequencies. Column can take two, so you can have an X and a Y variable. We can look at error bars, we can make density plots, we can make tile plots, which are sort of like heat maps. So there's a lot of options. All right, so now that we had our empty plot, let's make it more exciting and add one of these. So all we're doing here is adding the type of plot that we want to plot. And so here we're adding geom point, and we need to put this plus sign after the ggplot function to say that we're adding another layer. And so basically we could read this as we're using the orange data and we're mapping circumference to X and age to the Y-axis, and we're going to create a point or scatter plot. Okay, so it's very important that you put the plus sign just like this at the end of each layer. Otherwise, you'll run into trouble. So if you were to put it at the beginning of the next line like this, or if you were to use a pipe, these both will not work. Has to be a plus sign at the end of each layer. And that'll become a little bit more clear as we go along. All right, so here we have our plot again. So here is our ggplot function with our AES. I forgot the mapping here. And indeed it does work without mapping equals. And our plus sign and geom point. So what's cool about this is we can also assign this to an object, just like data frames and vectors. So here I'm calling it plot1, and when I type that in, then the plot will actually be generated. So if we take a look at our studio, you can see what I'm talking about. So the orange data is part of our studio, it should, or part of R, so it should come up. And so when I type this in, nothing happens except my environment will change. But when I type this in, we'll see, oops, that now I've generated a plot in the plot viewer pane. All right, so this can be helpful if we want to make multiple plots and keep track of different plots. It can be helpful to assign them to a plot name. But for the rest of the lecture, I'm mostly not going to do that so that I can just print the output on the slide. But here we're doing a similar thing. We've created our point plot. Here we're creating, instead of a point plot, a geom line. So that's all it takes to create a different plot, is to just change out the geom type. And I'm assigning this to plot2. And so now I can print out both of these plots, and here I can see them next to each other because I did something fancy with the chunk. But in general, this is how you would, see multiple plots, but we're going to show you how you can do some fancier things to have multiple plots together. All right, so let's say we want to add yet another layer. We can actually combine the geom point layer with the geom line. So we can use our plus sign to add another layer of plot. So this is the same code as before. We have our plus sign, and we're adding our geom line layer. So what this is really doing is it's creating the plot space first, and then it's adding on the points, and then the line is on top of the points. So if you ever wanted, for example, your points on top because something is being obscured, you would need to do genome point as the last layer. You can also add color to indicate different things inside the AES mapping function. So here we've done the same thing as before, just mapping the orange data with circumference to the x-axis and age to the y-axis, but we've added a color argument here, and we're using the last variable in our data, which is tree. And we have 5 different trees that are now colored, and so this separates out our data into different lines. Here they're just merged together. And so now we can see the different lines. And again, we're just doing the same layering of points and line plots. We'll look more at color in a bit. But you can also color individual pieces of the plot. And you can do that by specifying it within each layer. So here we don't have color specified, so we're not separating by tree. We just want to know in general, across all the trees, how does circumference change with the age of the tree in days? And so here we have just plotted the same plot as before. Oops, it's the same as this plot. The only difference now is that we've changed the way it looks. So we can add a size argument to change how big they appear. So here we've made the points much larger. We've made them red. We've added the color argument here to change the color. And we've added an alpha argument, which basically makes points semi-transparent or completely transparent. In this case, we're doing 0.5, so we can somewhat see a point underneath. So this is half, it goes from 0 to 1. If it's 0, then you wouldn't be able to see the point at all. If it was 1, it would be completely opaque, but we'd like some translucence so we can see overlapping points, which is very useful. We've also changed the size of the line, made it bigger. We've colored it black, and we've made the line type a different type. So we've made it to be a dashed line. We can also change the aesthetics of the entire plot by using theme underscore functions. There's a bunch of different theme functions to use. Here we're using theme dark. So theme underscore dark. So here the star indicates that there's a variety of different kinds. So it's the same code as the last plot, but now we're adding theme underscore dark, and this makes the whole plot look different. So if you click on this theme functions tab or link, it'll take you to a bunch of different types of different themes that you can use. It gives you examples of how they differ. So here's our theme dark. And it just changes the way the axes look. And you could actually do all of this manually, but it's nice that someone's already set it up to make it easier for you. All right, but now we can get even more customized. Now here's something we can't do in Esquisse. We can change the font. So we have a specific font that we need to use for a particular journal. They have a font requirement. So it's probably going to be Arial, and they'll be fine with that, but you never know. So in case you wanted to change the font type, you can do so here. So in this case, I'm using a different theme function. Theme, I think it stands for black and white, but BW, I've added a base size equals 20 argument here, which just means I'm making all of the font size 20. So here you can see in the last plot, it's kind of hard to see the labels. And so it would be nice to make them bigger. And I'm also saying base family to change the font of all of my labels. And I'm using Comic Sans MS. So if you're curious about changing font, you can use the fonts that are linked here on the slide as well. Although I would be wary about using this type of font unless it's sort of like a fun situation, but for publications or something that probably wouldn't be allowed. Yeah, another thing you could do to find these different functions and arguments in RStudio is start typing in theme, and you'll see information about the different themes, and just test them out, see what they look like. And so if you click one of these, you'll see the arguments that you can use, just like we did here. We use base size. All right. So often we want to change the labels on our plot. Maybe we want to add a title. We saw how we could do that with a skis, but I'm going to show you in a second how we can make it much more specific to what we might want. So in this case, we're just adding general labels, but there are a few arguments that we can use. We can use the title argument within the labs function, or the X or Y argument. The X specifies the X-axis label, and the Y argument specifies, oh, this should say Y-axis label. So here I have my title and my X-axis label and my Y-axis label. Okay, and so here you can see that I've added parentheses and information about the units, which would be a really great idea if you were plotting this for something official. You'd want people to know what we're actually plotting here, that this is in days and this is in millimeters. But sometimes we have a really long title and it can be annoying to have that on one line. So we can use a line break indicated like this inside the label function to specify that we want 2 lines. So here I want 2 lines in my title. So I say that it's a plot of Orange Tree data from 1986 or 1968. And I put the line break and I put the rest of my title here. So now I have 2 lines in my title. All right, other fancy customizations that we might want to make. And again, don't worry too much about how you would generate the first part of this code, because you could use skis and then you could come here and figure out, what are these other things that I can do to customize. So something that's quite important, I think, is to change the way in which the X-axis and Y-axis is plotted. So to change the scale of it. So we can use the scale X continuous or scale Y continuous to modify a continuous scale to change the breaks that it has. And we can use the breaks argument to specify that. So let's first take a look at our data. I'm just going to use the range function and pull to look at the values of circumference from orange and look at the range of those values. And I see that the smallest is 30 and the largest is 214. And when I look at age, the smallest is 118 days and the largest is close to 1600. So if I wanted to make sure that I had more breaks, because I think it's a little unclear where this point is on the plot, and I want to know more information, I can add more breaks here. And so I'll do so by using these scale X and Y continuous functions and the breaks argument. And here I'm just using our seek, which is short for sequence function, to specify what I want to do. So here, since I range from 330 to 214, I'm going to do a little bit below and a little bit above, and to make sure I show all my points. So I'm going to say from 20 to 240. So I choose these numbers so that I can choose a break that makes sense. So I'm going to do it by every 20. And for the y-axis, I'm going to go from 100 to 1600, and I'm going to go by 200. So that's going to add a lot more breaks to my axes, and it'll look like this. So this is what it looked like before without adding these scale X and Y continuous functions. But we can see here that we have it's much easier to figure out where exactly these points are. The plots are a little squished, so I could fit them on the screen, but you can see how this could be useful. All right. And then sometimes you want to zoom into particular data. And the way we can do that is by specifying our X and Y limit. So let's say that we're only interested in the data where the circumference is greater than 100. We could filter out our data and do it that way, but we could also just specify in our plot that we're only interested where the x-axis is 100 or greater. And so for that, we can use the x limit function, and we say that we want to start at 100 and we want to go to the maximum value of the circumference. So you can also put mathematical notation inside the x limit to specify min or max, which can be really helpful. So now we've zoomed into this part of our plot. Okay, so in summary, before our first lab session, ggplot2 specifies what data to use and what variables will be mapped to where. We do that using the mapping argument and the AES function, where we have our X and Y variables specified. And if we want to do color for the whole plot, not just a specific layer, we can specify that here. To add different layers, we need to put a plus sign at the end of each line of code. So not at the beginning, and we can't use pipes. So we have to be, ggplot's kind of picky about that. There's a bunch of theme functions that we can use, theme underscore, that can change the whole overall look. And we saw in our studio how we can find them by typing in theme underscore and just seeing what pulls up. We can specify lots of different things about individual layers, like size of points or lines, the color, the alpha, which was making things transparent. So it'll be more transparent the closer you get to 0, and less transparent the closer you get to 1. And different line types, there's more, even more arguments. And then we saw that we can use the labs, LABS, or labels function to label our X, Y, and title. And we can use line breaks inside of these to add line breaks. And it's got on the same line, but we have our X limit and Y limit function to either limit, zoom in on the data, or expand the plot area. And finally, scale X and Y continuous help us to modify the scale of the axes the way that we want. So ggplot's automatically going to plot every single point, including outliers. But then we can limit our X and Y axis to not show those outliers, or we can add for box plots and things where it might matter more, there's arguments to drop the outliers. Of course, you need to know if that's a good idea for your plot by knowing more about your data. But yeah, this would be a way in this sort of, line or point plot, if you wanted to limit, say we had a data point that was 3,000, we could do this, but instead say 1,600 here so that we don't show it. All right, I'm gonna copy the link here, and this is our data visualization lab. And I'll see you in there. Okay, so just following along with the slides, just did lab 1. So previously we saw how we could use theme underscore and something like BW or dark, and we could change the overall look of a plot. So we saw that back here, like this. But there's a theme without the underscore and a separate word, just theme and parentheses, that can help us to change various elements of a plot. So here we have just theme here, and it allows us to, in this example, change the size of just the title. So not the other labels, but just the title, because maybe we want the title to be larger. And so there's a general notation for this function, which we'll go over on the next slide. But basically, it just allows you to modify your plot for specific elements. Okay. So if you want to see more about how this function works, because it's a bit of a complicated function, you can, type in $theme parentheses, open parentheses, and add my share in our studio. So here I can see lots of information already coming up. And if I want the documentation, I can put ? And I'll see here in the help pane a bunch of information. So theme helps us to modify all sorts of different things. It can help us modify the title, text, lines, the axis title. It can help us modify axis ticks. You name it. It helps you modify to a very large extent. And there's information on what each of these does if you keep scrolling through the documentation. Can you see my slides now?
Yep.
Okay. So we saw that there's a lot of different elements that we can change. And then for each one, there's several things that we can change about them. And they have to make sense for whatever the object is that we're changing. So for example, if we're changing a title, it makes sense to change the text and specify the text. Because there is no line associated with a title, we're not going to be modifying lines. So when we look back here, we say we want to modify the plot title, and we're going to use the element text function to specify how we want the text of the title to change. So element line wouldn't make sense here because a title is not a line. It's consisting of text. And so that's the main one that you're going to need to use is element text. Element blink helps you remove things. So that's another useful one. These other two, you probably won't encounter too much. But the things that you can change inside element text and etc. are all of these different aspects. So you could change the size of the font, the color of the font, the type of font, whether you want it to be bold or italics, you could angle the font, you can make it transparent, all kinds of things. And you can position things differently. A lot of different things that you can do. So that'll take some time to get used to working with, but we'll show you some examples of things that are more common that you might want to change. So going back here to the previous slide, we're changing plot title by using the element text function, and we're changing the size to be 20, and the rest of the code is just the same as before. Okay, so someone asked about this earlier, and this is always a favorite. How do I center my title? And so Eskies actually helps you do this, but just so you know, this is the same code as I just showed you, where we changed the plot title to have size 20, but now I'm also adding this horizontal justification argument, which is hjust, to be 0.5. And so horizontal is this way. So I'm horizontally positioning this so it's basically at the midpoint of my plot and centered. All right, so I'm going to leave that aspect and I'm going to add even more. So I can just keep adding to my theme function by adding a comma, and adding additional things to change. So now I want to make my axis titles a little bit larger, but not quite as large as my title. So I can use element text again because I'm changing a text object, and I'm going to make that size 16. And so now I've changed these axis labels to be larger. I think that's looking a lot better personally. All right, and then this same function can help us to remove things, which is useful when we want to move around a legend. So legends popped up sometimes when we use color or to color or fill in objects. And so here I'm adding, we saw this plot before, we just added color equals tree to have these 5 different lines of different colors, and we see that there's a legend here. But let's say that we don't like this legend. We could use the theme function and find through the documentation what we do for legends, and we'll see that there's something called legend.position. There's a bunch of legend options, but position is the one that we want to use if we want to move it around or remove it. And so we could change it to be above the plot with top, to be below the plot with bottom, right, like it is, if that's the default. You could have it to the left, or ultimately, if we want to get rid of it, we would use none. And so this plot is generated with this code where we get it to the right by default, and then this code allows us to remove the legend. So again, if you're looking this up later and you want to remove the legend, first of all, you can Google it. It's something that I had to do a lot when I was first learning ggplot2. But remember, you can always type in $theme and see it in the help pane here. And here you can see legend position, and it says here what that means and what the options are. Okay. In case you're interested, you can also make your own themes. So if you have branding that you want to use for your organization, where you use a particular set of colors and you always have your title be a certain size and your axes be a different size, for example, you can do that. And we're not going to go into it in the class, but I just wanted to make you aware that that's something possible and provide a resource that shows you how. Okay, so sometimes we need to do something special to make our plot look okay. So to demonstrate that, we're going to create some data, and this data needs to be a bit more complicated. I created some data so that we could still have a good example of this, but so that it wouldn't be too complex. And so I'm going to go over how we create the data, and I'm going to copy paste the code. So if you're following along, you can copy this into your RStudio. Okay, so there's going to be two different categories of food items. We're going to talk about pasta and rice. Let's say that we work at a grocery store and we're trying to figure out what's selling and how that's fluctuating with price. And we have 4 different items. So we have 2 different types of pasta and 2 different types of rice. We're going to track their price values and how they change over time. And we're going to look at that 10 times. Okay, so the way we're going to do this is first, we're going to create a repeated vector of the character string pasta and rice, and we're going to repeat this, each of them 20 times. And this is to generate 20 pasta values and 20 rice values. So if you type that in, you'll see what that looks like. Put this in the chat. And then make sure you fix your quotes if they end up being curly when you copy paste. And you don't have to follow along. I just know that people like to. So I'm trying to provide this in an easy way. And then I'm going to provide the item ID. Remember, I have 4 different items. I have 2 of each category. So I'm going to repeat the sequence 1 to 4. And I'm going to do that 10 times. And that'll work because that'll give me 40 different values, just like the first vector. And then I'm going to paste ID in front of each item. I can use this paste 0 function to do that. So this will just modify the item ID. And then I'm going to make an observation time. So we're going to check the prices 10 times. And then I'm going to make random price values. So I'm doing that by using the sample function, and I'm just randomly creating a range of values that it might take. And ultimately, I'm putting this all together into a data object called food, a tibble. Again, you don't need to type all of this in, but I know that if some of you like to follow along, so if you are trying to, this is how you would generate the data. So here's what our data looks like. If we look at the food object, we see that we have our ID value for which item it is, our category, which is categorical pasta or rice. We have 10 different time points for each ID value, and we have a price fluctuation. Okay, if we make a plot of this, and here we're going to use observation time as our x-axis and item price change as our y-axis. And we're just using the same notation that we did before. So we've got ggplot and our food object and our mapping with our ADS aesthetics. And we're adding a layer to create a geom line function plot. So this looks a little bit strange, right? I don't know about you, but I have trouble seeing what's going on here. And sometimes this happens. So if it looks confusing to you, it probably is, and there's probably something wrong. And so, play around with the variables. Think about like, are these variables that I do really want to plot here? Or maybe I need to do something involving groups. And so this is where the group argument of the AES function comes in handy. So here, this is looking really weird because we have different items with very different ranges of changes. So here I'm using group equals item ID so that I can also plot the 4 different items. And when I split that up, this looks much better, right? So it's the same exact plot. The only thing I've added is this argument. And now I can see how the item price has changed over time. And it makes a lot more sense. It looks a lot better. If I were to use color instead for item ID, it would also automatically fix that issue. So using color will automatically group the data. So that's also a good option. And that looks quite nice. But say now I want to look at item category, which was the rice or pasta. This is looking weird again, right? And that's because we have different items within each of the 2 categories. So sometimes we're going to need the group argument and the color argument. So when I do that, I'm grouping by the item ID and coloring by item category. I color by item category so that I can see which line corresponds to rice and which lines correspond to pasta. So it can get a little bit tricky, but the best way to deal with this is to just try out different values, different variables, and try the group and color arguments. And remember that these are in our mapping part of the ggplot function. All right, another way that we can deal with this is using facets, which Ava covered a little bit yesterday in Eskies, something that you can do with Eskies. So we can use 2 different ways. First, we're going to start with just facet grid. And to use this, we add a new layer. So we add our plus sign after our geom line. And we need to use this tilde sign, which is typically on like the left corner of your keyboard. And that's saying, this is what I want to facet by. So in our code here, we're going to do the same exact code that we've done previously. But now we're going to facet by item category. So whether it's rice or pasta. And that's going to create a grid. That's why it's called facet grid. We're showing 2 different facets of the data. So 2 different aspects of the data in a grid shape. So they're right next to each other and they have the same Y and X axis. And now we've split up our rice data and our pasta data into 2 kind of subplots, if you will. So this is what it looked like before. Or really this plot here, where we just have color. And now instead of using group, we can facet. So it gives us a similar type of plot to this, but we get a bit more information because not only are we seeing which lines are pasta and which are rice, but we're also getting ID information. So generally when your data gets more complicated, that's when you want to start using facets. All right, So there's also facet wrap, and facet wrap is a little more flexible than facet grid, because grid has to be in a grid format. Facet wrap instead can do a more flexible thing, like you can specify the number of columns that you want or the number of rows, and you can have a different shape. And because of that, it allows you to specify whether your scales or your Y or X axis should be the same or not. And so there's some arguments about scales that I'll go through here. So if I use scales equals free X, that means that the X axis can be different across the two plots. If I use scales equals free Y, then the Y axis can be different. Or if I just use scales equals free, then they can be different in general for both axes. So if they happen to have the same scale, just naturally the data is across the same span, then nothing will happen. And so we'll see that for our X axis in our data. So here we're gonna put this all together. So we're using facet wrap now instead of facet grid, but the same general notation. We're gonna do it by the item category, whether it's rice or pasta. And so here we see the top labels of our facets of our subplots have to do with the item category being rice or pasta. And I'm going to specify that I want these stacked one on top of the other. So I'm using n number of columns equals 1 to do that. And so you just need to pick a number that would make sense with your data. So if I were to do number of columns equals 3, that would not work because I don't have 3 plots. And then I'm going to say scales equals free, which will allow my y-axis to change and my x-axis if there's something changeable. But in our case, the x-axis follows the same span. So the x-axis stays the same. But because our data spans different parts of the y-axis, I see a difference in the y-axis between the two plots. So the span here is from 0 to 2.5 for pasta and from 2 to 8 for rice. And this can be really helpful if you have, for example, widely different ranges of data. Then it's nice to allow for different scales because it kind of allows you to zoom in on that data and compare different groups. Okay, so just a few tips. And again, like a lot of these aspects you can come up with the skis, and then you can do this customization that we talked about with the theme function. But we wanted to give you a general sense of how to make these plots. So looking at color versus fill. So Ava talked a little bit about this. Generally, we want to use color for outlines of things. So color works really well for points and lines. And when we use it on a box plot, it's going to create an outline. So here I'm using my food data, and I'm mapping item ID to the x-axis. So I had 4 IDs, 4 items. I have item price on the y-axis, and I have the color being item category, so whether it's rice or pasta. And here we can see in our geom box plot that we have the outline of the box plot colored, which is okay, but maybe that's not quite what we want. Typically what we want is to use the fill instead argument, and so that would fill in the box plots with color. So that's something to keep in mind. It's also a good idea if you're making box plots to add a jitter layer, and that can be created with geom jitter. So here I'm using the same code that I just did on the last slide, where I'm filling by item category, but I'm adding a geom jitter layer, and I can specify. So what that does is adds points on top of our plot. So we can see where the individual data points are and how wide they range, which is really good for showing the data. And we can specify how wide we want those points to be plotted with the width argument. And so this provides much more information about what's really going on in the price changes across these different items. It's important to think about color vision deficiency or color blindness. So red and green are often not a good choice for that. And so we can fix this using a couple of functions. There's scale fill viridase, which we can use _D for discrete data or _C for continuous data. And again, this is an option in a skis, but if you wanted to always make your data colored in a way that would be discernible to different forms of color blindness, then especially red-green, then adding this would help. So here I'm using discrete data because I have categorical data between pasta and rice. And so that's why I have to use the _D. But if I were plotting numeric values and I had different points, I would want to use the _C for continuous data. All right. So another useful thing to know is that you can actually wrangle your data and then pipe the wrangled data into ggplot. And so this is really useful if you don't want to actually create a new intermediate form of the data where you just needed to wrangle it for this particular plot. So here, for example, I want to take my food data and figure out the maximum price change for each category of food, whether it was rice or pasta. So I'm using the group by function to group by item category. And then I'm summarizing the data to create a new variable called max price change. And I'm getting the maximum value of item price change. And so I could do something like that to pipe the data into my ggplot. Okay, if you type color outside of AES, outside of the aesthetic mapping, that's going to add an outline to things. So if I'm doing a geom column, that's going to add an outline of black to my geom instead of actually making these black. So that's another thing to watch out for. So I'm showing you all these tips as things that you might encounter as you continue to practice, but this is just to demonstrate what could happen if you're trying to do fancier things with ggplot, because a skis can help you get most of the way. So I'm just giving you some general tips. So I would recommend that you continue to use a skis to just get used to the plot and see how ggplot is working now that we understand more of the basics. So another thing to keep in mind is geom bar can only take one argument. So one AES mapping, so either X equals or Y equals, whereas geom column can take two. So if you run into that issue, that is why. And also be really careful to check your plot because sometimes you're not plotting what you think you are. So here's an example of how things can go wrong. And it happened pretty quickly here. So we're doing a pretty simple plot here. We're doing a similar mapping to what we did with our box plot. But this time we're using geom column. And this is particularly a type of plot where things can go wrong. So, and generally it's better to do box plots where we can see the range of data. But let's say we were trying to make a column plot. So if we look at our y-axis, we can see that the item number 4 has had a price change of up to 80. And if we remember our data, that does not seem right. Does it seem like rice would fluctuate by $80? Probably not. So something weird happened. And indeed, even the smallest amounts are pretty large. So our y-axis looks strange here. So if we would check our data, we can see, is this right? So we look at the head and we see that the item price change seems pretty small here for these first values, but we're, ID 1 is kind of small. So let's look further. So let's summarize our data. And if we look at the sum of each of the price changes for each of these different objects or food items, we'll see that that's actually what we're plotting here. So this goes all the way up to 77. And that's where we're plotting. So what we've actually plotted is the sum of the price change, item price change, what was on the y-axis. And that's probably not what we want. So instead, we probably want to get the mean value. And so we would first need to do some wrangling and summarization like we learned in the summarization module. So we would group by item category and maybe item ID and summarize by the mean of the item price change. And we're going to create a new variable called mean change. So this is what we covered in the summarization lecture. So here we see now we have a new output, a new tibble that we've created from using summarize, created this new column called mean change. We have our 2 different types of categories, our 4 different items, and now we have the mean change in price, which only goes up to 7.7. So then we can use what we've wrangled to pipe that into our ggplot. And we need to modify this so that our y-axis represents what's actually in our summarized data. So we can't just use the same item price change for our y value. We need to use the mean change for our y-axis. And here we see now a column plot that has the appropriate values. So the whole point of this is to show you that indeed you can wrangle the data before you put it into ggplot, and also that you should check your data and make sure that it looks right in your plot and that you plotted what you actually intended. This doesn't happen a lot with line plots or point plots, but it can happen with column and bar plots. And again, like typically it's better to show box plots if you can, if you have like a range of data. So one way is to just kind of avoid using geom column and geom bar. Another really important point that people forget, and that's a really an important practice to keep in mind, is that it's good to make the labels on your plots large enough for people to read. And this is especially important for publications. So when you save your plot, you often have to shrink the plot to fit inside your document. And so it's helpful to change the font first. So we can change all of the text at once using our theme function. And remember, we have to use the element text because we're using text, and we're going to change the size to 20. So I'll make it all big. Okay, and then I'm just going to go over some other packages that could be useful for you if you have special things that you want to do. So there's a package called Patchwork, which helps us to put plots together. And this can be really useful sometimes if we want to do more than just facet. We actually want to put different plots of different data sets together. And basically how it works, you would have to install it and load the library. You can basically kind of do mathematical notation to describe how you want your plots to be shown. So here I'm adding these two plots together and dividing by plot 2. And so it puts these stacked next to each other and puts this below it. So check out that if you need to combine plots together. The direct labels package is super helpful if you have a lot of different lines that you want to identify. And so sometimes we end up with 20 different lines on a plot or more, and there's not enough colors to indicate what those different lines are. So the direct labels package is really helpful for adding those labels onto the lines themselves like this. And so again, you'd have to install and load that library and learn how this package works. But we're just providing the resource in case that's something you run into. Plotly allows you to create interactive plots. So this is a plot that I already created earlier in the lecture, and I'm just using ggplot2 function around it. And now I can show what these individual observations are when I hover over them, because it's now interactive, which is pretty cool. It was very easy. I just had to use one function around my plot. There's also a ggiraffe or giraffe, I'm not sure how you're supposed to say it, package that's also really helpful. Okay, so, and then finally, one really important thing to cover is how to save plots. So there's a few different ways. You can use the RStudio menus and go down to plots, export, and save. Or you can use the zoom. I'm going to demonstrate each of these and save from there. Or you can actually use the code, which is probably the most preferable. I don't know, they're all helpful though. But to use the code to do it, you would use the ggsave function. So you have to specify what the file name is going to be for the new plot, and it'll automatically save it wherever you're working. And you need to specify what object or what plot object is the plot. So you need to assign your plot to something. And then you can say what dimensions you want it to be, which is by default in inches. And so in RStudio, I have a plot here. I can export this here to something and save it. Or I can press this zoom tab. I assume you can't see my zoom. Is that correct?
Can't see your zoom.
Yeah, so let me try to make sure everything's down. Reshare. So I can click the zoom button here in the plots pane. Now you can see it, I think.
Uh-huh.
And I can resize my plot however I want. And then I can right click and say save image as. And save that plot somewhere in my files. Or I could even take a screenshot. All right, so in summary, our theme function is what's going to be really helpful if we want to customize certain pieces of our plot. And it's a tricky function, but looking at the documentation is the best way to go. And we can do that by using $theme and our parentheses with nothing inside. The most important one that people find tricky is legend position equals none to remove a legend. or you could use top or bottom or something to change the location. To change elements of text, we're going to need to use the element text argument or function. And we can use different arguments about how we want the text to be formatted. To center a title, we need to use the H or horizontal justification, HJust, and set that equal to 0.5. Sometimes you'll find that your plots look a little bit strange and you need to start using the group argument within your mapping, or you might need to try color or both, or even facets. So just keep that in mind. Make sure you check your plots to see that they're really plotting like you think they are, that the numbers make sense. And when you're using facets, the grid always makes a grid, so you can't have free scales, but facet wrap will allow for free scales. And you can specify either free.x, free.y, or both to be free. Use fill instead of to fill in box plots. So we also provide this resource as a guide for more information on how to use best practices for plots, like how to not make distorted plots that are misleading. So that's the end of this lecture, and we'll go to the lab after our break.